My name is Konstantinos Gavril. I'm a teacher of physics, and the video you're watching has to do with a voltage divider circuit in a DC current. And what is a voltage divider? As you can realize from the expression, voltage divider is a circuit that divides the voltage. Okay, we are going to see how this is happening. Now, first of all, I want to write you the voltage divider formula here in order to explain you what happens. We have the V1 above R1, which is equal to the V total, okay, above the R total. What do we have here? We have V1 equals to V total above R total times R1. Okay, from here we arrive right here. So we divide the 6 volts, okay, in two parts. And as you can realize here, because we have the same value of the resistors, we are going to have the same value of the voltage across each one of them. Let's see in the Falstad simulator what happens. We are going to fill the tables, yes, that the exercise asks from us to do. We have here the table 1, the table 2, and the table 3. First of all, we are going to make, to draw this current, this circuit to the circuit simulator, and after we are going to apply a 6 voltage to the voltage source here and 9 voltage to the voltage source, and we are going to see what is the value of the voltage drop across each one of these two by using a voltmeter in a parallel way connected. Now, let's see our simulator. We are going to use the draw tool. From draw option, from the toolbar, we are going to input source, add voltage source with 2 terminals right here. I'm going to draw also a wire right here. Okay. I'm going to add wire again. We are going to see why. Between the components, between the parts of the circuit, I use to connect wires because it's easy afterwards to insert there an ammeter. I'm going to use another wire here. Okay, I will insert another resistor here. Afterwards, I'm going to close my circuit this way by using this. So this is my circuit. I'm going to make it a little bit more nice. Select and drag tool. But from the select and drag selection, we can select the part of the circuit we want and to make it larger, big, smaller, or what else, or to move it. Okay, move it. Now I'm going to choose this wire. I will bring it here. Whoops. I'm going to choose the connection, and that is okay. I will double click in order to insert a 6 voltage value to the source. Here is 6 voltage. Here I am going to insert. What do they ask me to do? Measure the current at link A. You see, here I have for this table current in point A. Yes, sir. I'm going to enter here an ammeter. I will remove the wire and I will insert an output, because an ammeter is an output device. Output. Here it is. We are going to put it here, join it, and it is ready. As you can see, we have 3 milliamperes total current, which we are going to write it in the table. Now we are going to enter add wire in right here, or let's input outputs for a voltmeter first of all. Voltmeter in a parallel way here and in a parallel way here. Okay, in order to add wires and connect them here to the right points, here and here. Be careful, the connection points. If I leave it somewhere here, you see I have a red point. So in order to remove it and to put it in a right connection join connection point, I'm going to drag and select my wire, and I'm going to move it right to the connection point. I'm going now to add wire here to the next voltmeter, and as you can realize, we need to put also, we have 3 voltage. We double click on the resistor in order to make it, as the exercise asks from us, 10 kilos here, 10 kilo ohms. This means 10 kilos. Okay, 10 kilo ohms here. Apply and apply. What do we realize? We realize that here we have, let me show you, here we have 3 voltage drop, 3 voltage drop, 3 okay, because we have 10 kilos and 10 kilos. So we have divided the 6 volts by 2 equal parts. 3 plus 3. Let's see what happens, and first of all, let's enter these values to our table here in order to finish with this table. I'm going to insert my 3 milliamperes, my 3 and 3 value here, right here, and I'm ready. You see, I have, let's put it in a right way, center, okay, center and center. That's right. Something like that. Okay. It's okay. Now, almost. Now we are going to put the voltage source in 9 volts. Okay. Double click on the voltage source, make it 9, apply, and okay. What do we realize? Again, the voltage is divided by 2, equal. Okay, we have an 10 kilo ohms resistor and another 10 kilo ohms resistor in a series way, and this kind of circuit divides the 9 in 2 equal parts, 4.5 and 4.5 volts. This is the value we are going to enter in the table. Also, as you can see here, I will double click to the ammeter because I want milliamperes. And what do I have? 450 microamperes. So I will go to double click. I have double clicked on the ammeter. I have the scale option, milliamperes, apply and okay, ready now. Now let's go here to apply our values, 0.45 here for the current, and here I have 4.5 and 4.5, also 4.5 volts across each one of these two. Okay, because the resistors are equal. Now we are going to continue with the change of the values of the resistors, we are going to have 1 kilo ohm and 10 kilo ohms and 9 volts to the voltage source. Let's do it. Double click on the voltage source, leave it 9. Okay, this is okay. But here I'm going to choose 1 kilo ohm and you are going to see what happens. Apply here. Okay. You see now that I have 818 almost point, the other after the comma, I don't care about them so much, millivolts and 8.182. Let's see what does this mean in a few words. As you can see here, I have this value, and here I have this value. But also, I see here that I have 1 kilo ohm resistor. The R1 is 1 kilo. And the other one, you see, it's 10 times bigger. So I have a 10 times R1. As you can realize here, the resistor is 10 times higher. The resistance of this resistor here is 10 times higher. So what does this mean for the value of the voltage? The voltage here is again 10 times this value. As you can realize, if I multiply 8, let's make it a little bit thinner, my pen. If you can see, if I multiply by 10 this value, I will get, oh, I'm sorry, if I multiply by 10, just a moment, because here we have a value of, you see, this needs to be 10 times bigger, but here I have a millivolt and here I have a volt. So I need to change the scale. Of course, the scale here must be volts. Okay, apply and okay. Now we're okay. So as we can see here, now we have volts and volts. I have this times 10 equals to 8 point, comma, 1, 2, 1, 8. Okay, which is this one? Okay, the number 2, I don't care about it. It's the third digit. Uh, I don't care about this third digit. Okay, but as you can realize here, what happens? I have uh, the voltage drop across the R2 to be 10 times higher. Okay, why? Because the R1 and R2, this is the R2, the R2 is 10 times R1. This one is 1 kilo and the other one is 10 kilos. Here I have 1 kilo ohm and here I have 10 kilo ohms. So I have here 0.818 volts and here 8 point. From here to here, I go by multiplying by 10 from here to here. And also from here to here, I go by multiply by 10. So the same thing that happens to the resistors, the same thing happens to the value of the voltage across them. Okay. Now, this was the main meaning for this division. We have a divider that divides the voltage as we want to be divided. And we can choose the specific resistors in order to divide the voltage in the way that we want to be divided. Okay, okay. Now let's clear this one. Let's go to the here. Okay. I'm going to erase all this stuff from my screen, and I'm going to enter here the values. Here I have the power supply to be 9 volts. Here the amperes, the current is, as you can see, 0.818, 0.818 milliamperes. Okay, here. The voltage across R1 was 0.81. How much it was? 2. 818 volts, and here was 8.81. I don't care about the other number. Okay, it is 2, but it's okay. It depends on the uh, it depends on the voltmeter errors. Okay, you see, as we can see here, I am going to insert an explanation. Okay, as I can see, 0.81 becomes multiplied, multiplied, whoops, multiplied by 10 equals to 8.1. Okay, now this is it. By the same way, I'm going to realize I will choose the 2.2 kilo ohms and 22 kilo ohms here. I will leave the voltage at 9, the value of 9, and I'm going here to choose 2.2 kilo ohms, 2.2 kilos, apply, and the other one to be 22, 22 kilo ohms, 22, apply here. So as you can see here again, I have 10 times higher voltage, higher resistance from here to here. This is 10 times higher. This one, the 22 kilo ohms, have come from 2.2 times 10. This will happen again to the voltage drop. When the resistor's value is multiplied by 10, the voltage drop across the same is multiplied, the same resistors is multiplied by 10. So you see that I don't care about the value of the resistor, but I care about the relation between these values. The relation is that the R2 is 10 times R1. The value of R1 before we had 1 kilo ohm to be 10 kilo ohms. And now we have 2.2 kilo ohms to become 22 kilo ohms. And as you can realize, in both situations, we have a multiplication by 10 here and here, and we get the same value of the same value, I mean, with the one before. Okay, we are going to insert these values here. You see, I use the PDF filler because it is a very interesting PDF tool in order to enter values in a PDF file. So here I have to insert here 9 because this is the 9 volts. I want the, you see here it is 0.372 the milliamperes, the current 0.372 is the value of the current. Okay, and here now I have a 0.818 8, 1. Okay, I have an 8 also, but I don't care about that. And here I have 8.812. Okay, this is 10 times higher. Again, I'm going to tell you that you see here I have a 0, 8.8 and 8.818 or 812 because we have the ammeters mistakes of working. Okay, it is 10 times higher. This value is 10 times higher than the other value. Okay, and this is the main point for the voltage divider. If we want to divide a value of a voltage, we choose a series circuit of specific resistors values in order to divide, okay, our voltage. So this was the voltage divider circuit. We are going to continue with some more practical exercises.